your chapter. You can see the board okay this morning. So I'll go through each question on the assignment. If you have your assignment with you, you can mark it as you go, and you'll have a fairly decent idea as to how you did on it. So the first question was the graph of the reciprocal represents the reciprocal of which quadratic function? All right. So what I did in this question is I understood that there were asymptotes at -2 and +1. So that means that in the original equation there were roots at -2 and +1. So what I did is I wrote out my root values. So x plus 2 times x minus 1. I FOILed it. And I ended up with x squared plus x subtract 2. Now, you could have, you had the access to it. You could have punched all 4 into your calculator and done it that way to find out. But this is probably the easiest way to do that question without doing the process of elimination from it. So the answer in this one was A. B, one of the vertical asymptotes of the graph. So the vertical asymptotes always occur when the denominator is equal to 0. So I have x squared minus 16 equals 0. That's a difference of squares. I could also just add 16 to the other side and square root it, and I would still get the same answer as 4 and -4. So the answer for number 2 was B. Okay. If I get going too quick, just ask to slow down here. All right. Okay. C. Consider the function, the absolute value f of x equals the absolute value of x minus 3. Sketch the graph of the function. Okay, so I said the easiest way to graph it is to draw your original function and then reflect it up over the x-axis. So 0 and -3, 1 and 1 comes over here. So this is the graph of y equals x minus 3. All right. And then we understand that the absolute value, I can't have a negative value to it, so I reflect it up and out. So 1, 2, 3. So there's my original graph. I'm just going to draw this in here for later on. Okay, so the dark blue, the solid blue, that's my graph of y equals x minus 3, the absolute value of it. It says determine the intercepts. So the intercept is the x-intercept is 3. The y-intercept also 3. All right, we're talking about the absolute value, so I can't have that y-intercept being a negative number. State the domain for this graph. How far left does it go? How far right does it go? So the domain, x is an element of all reals. And the range for this graph, there were some struggles here. Remember, ask yourself the question, how low does it go? Well, it goes down to where y is equal to 0. That's as low as it gets. All right? So, and then all of the values are greater than that point right there. So the range for it is y is greater than or equal to 0, where y is an element of all reals. Okay? And again, you can use either notation. Sorry, lost you for a second. Both of those are acceptable notations for this. All right, and the piecewise form of this function. All right, so this is y equals x minus 3. That was that red graph. This one over here is y equals negative x minus 3. So for the piecewise, and I'm explaining what part of this graph did I use. Well, the red line here to the blue line here, that is the part of the graph that I use right here from x equaling 3 and then going to the right. So I used where x is greater than or equal to 3 here. And then for this other graph, this blue one, which goes in the opposite direction, I used all of the values on that graph where x was less than 3. So this to the left here, that to the right. Okay? So for piecewise, and all I have to do is just write out the two equations. Write out the first equation, the original equation, and then I write out the second equation as a negative value. Okay, any questions about that? Okay. All right. The next question. This one was a little harder to do. So I'll do it both ways here. So I have the absolute value of 4x squared minus x minus 4 equals 3x subtract 1. And then I have 4x squared minus x minus 4 equals, and it's the negative of the right side. So negative 3x subtract 1. So I'm actually just going to switch both the signs there. All right, I put the negative in front of the bracket here, and then I distribute. So I end up with negative 3x plus 1. I'm just saving space here. So it's equal to the positive. It's equal to the negative on both sides of it. All right? Okay, so let's solve this guy first. Subtract 3x and add 1. So I get 4x squared minus 4x and minus 3 equals 0. Choo-choo. I just want to make sure I got it written out. I want to make sure I got it done right. Oh, where did I put it? Well, I'm not sure. Okay. Oh, you know, never mind. I put it. There we go. Nope. All right, sorry about that. I'm losing my train. Okay, so let's go through this now. So this is factorable. Okay, 4 times negative 3 is negative 12. The factors of negative 12 that give you negative 4 would be negative 6 and 2. When I reduce it all by using my greatest common factors, I make this 2x and this 2x here, okay? 3 and 1, and I need a negative 3 here and a plus 1 here. Okay, so 2x times negative 3 is negative 6. 1 times 2x is plus 2. That gives me negative 4 there. 1 times negative 3 gives me negative 3. All right, so what I end up with is x equals negative 1/2 and 3 over 2. Okay, and what I find out is that this negative 1/2 ends up being an extraneous root. So the first solution is 3 over 2 for that. Okay, now I do this side. So I end up with 4x squared plus 3x, and what is that? Subtract 5 equals 0. Is that right? No, 2x here, sorry. 2x. Okay, what I discover is it's not a factorable expression, okay? So I'm going to use my quadratic equation times 4 equals. All right, so I end up with minus 2 plus minus the square root of 84 over 8, okay? So 4 times 4 is 16. 16 times negative 5 is negative 84. Subtract negative 80 is 84. I can actually reduce this. So it gives me minus 2 plus minus 2 square root 21 over 8, which is equal to, so I would reduce it down to here. I'm going to write this out. So I get minus 1 for it. So I keep going in and out today. I don't know. My internet's a struggle. So sorry, I'll back up a bit. So I took a 2 out of here, a 2 out of here, and a 2 out of the 8. Divided them out, that leaves me minus 1 plus minus root 21 over 4. And as a decimal, 89564 and negative 1.3956. And again, this is an extraneous root. So my solution for this question is 3 over 2 and 0.89564. And again, you could check your answer by graphing and seeing where they intersect. And that would have helped you with that question. But the algebra is important for us to do. Okay? We want to make sure that we have good algebra skills when we get into grade 12 because we do a fair bit of it. All right? So for 5 marks, you had to get to here and exclude the 2 extraneous roots. All right? This part right here, if you got to here, I was okay. And then went to there. That's fine. This is just practice. All right? Okay?
Mr. Newton, how do you know that those are extraneous roots?
Well, in all honesty, Austin, what I did is I graphed it. And I saw that there was only 2 intersection points. Okay? So I graphed my y1 was the absolute value of 4x squared minus x minus 4. And y2 was 3x minus 1. And I saw that there was only 2 intersection points. And that's where those 2 intersection points occurred. We're at 3 over 2 and 0.89564. Now, you can plug them in to the original equation. All right? So you would put them in for x in the original equation, and you would see that the left side and the right side do not equal for these other 2 here. All right, that's your other option. Okay, so the quick option is to graph it, see where your 2 intercepts are, or where they intersect, sorry. Okay, and then the second option is just to plug it back into the original equation up here, and you would see that the left side and the right side don't equal. All right. Okay. Go to the next one. Everybody's okay. So it says solve the equation, the absolute value 2w minus 5 equals 5 minus 3w. So when I'm asking you to solve it by graphing, I need that intersection point. There's a number of you that graphed it great, but didn't actually write in what the intersection point was or what the w value was. So for this question here, I go y1 is equal to 2w minus 5, or x minus 5 if you're putting it in your calculator. And then I have 5 minus 3w, just like that. Okay, whoops, sorry, my bad. That should be absolute value. Okay, so All right, so 2w minus 5. 1, 2, 3, 4, and 5 is down here. And then 1, 2, 3 is out here. Okay, so this coordinate right here is actually 2.5 and 0. All right, and if I put 0 in, so I add 5, I put 0 in for y, add 5, whatever. So the long and short of it is I end up with this 1, 2, 3, 4, and 5 right here. So okay, so there's y1. This would be my y1. And my x1, or my x1, my y2, okay, I go to 0 and 5, which is right here. I go down 3 and right 1 to right here. All right, here's my intersection point right here. So my intersection point in the answer to the question is either that or that. W equals 0. Either one is an acceptable answer or solution for that question. All right, I just need to know where they cross at. I need that intersection point. All right. Again, you had you have use of your calculator, so there was nothing wrong with you checking it on your calculator or working through on your calculator. All right, the two graphs were two graphs of lines, so it wasn't really a difficult one to work through. Okay. All right, the last question now is determine the reciprocal of f of x equals 10 minus 5x. So f of x equals 1 over minus 5x plus 10. Okay. Or if you put 10 minus 5x, that's fine. State the equations of any vertical asymptotes. So I said this before, the vertical asymptotes occur where the denominator is equal to 0. So I subtract 10 and x is equal to 2. So that's where my vertical asymptote is going to occur. Now, what I would do is I would graph minus 5x plus 10 first. So,
Mr. Newton,
yeah.
I think you skipped question 6.
Oh, I did too. It's on the back page. Thank you. Okay, I'll go back to it. Thanks. Yeah, I'll go back there. Sorry, I didn't see it on the back page there. Thank you. Okay, so 5x plus 10. Oh, and then it goes through. So I go to 0 and 10, which is up here, comes down to here. All right, and this would be my line here. Okay, so there's my original graph of y equals minus 5x plus 10. Now what I need to do is mark in my asymptote and then my invariant points. So my asymptote occurs like this. Now this is extremely important. The one thing that you have to do, because your calculator doesn't do it for you. Your calculator will not draw in asymptotes. So it's important that you label the asymptote by putting it in here. Okay? Then I go to 0 and 1, which is right here, and where it's equal to 1, y is equal to 1 and negative 1. And then I draw out my my shape. There. And there. And lastly, Again, important. You need to identify that this is also an asymptote. All right? My lines are going towards that where y equals 0 but doesn't hit it. Okay, so it's important that we do that. Now, so there's my graph. My graph is not that difficult to do. Again, you have technology to assist you, but the problem with the technology that you have is it won't draw in your asymptotes for you. So you have to understand that they're there. Okay, so that was 3 marks. It says, what are the equation of the asymptotes? The asymptote equations are x equals 2 and y equals 0. All right, lots of us missed that y equals 0, but that is an asymptote. That's why these graphs, because as x gets larger, y gets smaller and smaller, but does not hit 0, because I can't get there because they're all fractions. The invariant points, these were not as easy to find. So if you wrote them as decimals, that was fine. Again, I'm okay with that. All right. Okay. Now, here's the last thing. All right. I want you to see something. This is kind of the game changer right here. If you actually understand reciprocal function. The y-intercept in this case, for this line, the line of negative 5x plus 10, the y-intercept was 0 and 10, right? So I'm taking 1 over all of my y values, all right? I'm reciprocating all of my y values. Well, if it crosses right here at 0 and 10, then the reciprocal has to cross down here at 0 and 1 over 10. All right, that's what reciprocal is. I take 1 over all of my y values off of this red line right here. So my y-intercept then down here is 0 and 1/10. And then what's the x-intercept? It never crosses the x-axis. All right, it doesn't cross the x-axis. So going back through, determine the reciprocal. That's the reciprocal. State the equations of any vertical asymptotes. I have to solve for this equaling 0, so x equals 2. That's where the asymptote comes in for the vertical. Sketch it. So I sketch my original. I mark off where the asymptote is here and where 1 and negative 1 are, because 1 over 1 is still 1. 1 over negative 1 is still negative 1. All right? And y-intercept, it crosses here at 0 and 1/10, because this guy crosses at 0 and 10. Okay? Any questions about 7? All right, I'll go back. I missed 6. My bad. Monday, forgive me. Okay, so I got absolute value. X minus 10 equals x squared subtract 10x. And then x minus 10 equals negative x squared plus 10x. Okay, so for this question here, again, x minus 10 is equal to the positive of this and the negative of all of that. So 0 equals x squared minus 11x plus 10. 0 equals x minus 10, x minus 1. X is equal to 10 and 1. I go over here. X squared minus 9x minus 10 equals 0. X minus 10, x add 1 equals 0. X is equal to 10 and negative 1. So I'm doing that fairly quickly. That's the factoring part. Now, if I use my original equation and I substitute in 10, 1, and negative 1. All right, if I put 10 in here, 10 subtract 10 is 0, that's 0. 10 squared is 100, 100 subtract 100 is 0, 10 works. Okay? Put a 1 in here. 1 subtract 10 is negative 9. The absolute value of negative 9 is 9. 1 subtract 10 times 1 is 1 subtract 10 is negative 9. This guy does not work. All right? If I put a negative 1 in here, negative 1 subtract 10 is negative 11. Absolute value of negative 11 is 11. Negative 1 squared is 1. 1 subtract 10 times negative 1, that is also negative 11. It works as well. So my solution for this is 10 and negative 1, and my extraneous root is actually positive 1. All right. Are there any of these questions you'd like to go back and see or have a better explanation of? We're okay? All right. So that concludes, what is that, Chapter 8? The wrap up on Chapter 8? Okay. All right. I'm just going to save that into my files here. All right. So this section on Chapter 9 is working with inequalities again. So something that we've already done and applied. So that's the beauty of this one is we've already seen it. So we need to be able to graph and shade regions on a graph. So we're talking about inequalities now rather than equalities. Okay, so we're shading regions. Now, I'm just going to go through. So let's go to page 364. Again, because you've done this, I don't need an entire explanation. I'll explain the little pieces and the nuances to it as we go. So it says graph a linear inequality of the form ax plus by is less than c. Graph and label the linear inequality 4x minus 3y is less than negative 12. Okay, so first things first. So it wants us to graph that. So what it means is that I need a shaded region for it. All right, I'm not talking about graphing a line and all the coordinates just on the line. The coordinates in a certain area are also going to satisfy this equation. So if you recall, the first thing that we do is we change it to an equality and we graph the line first. So I'm going to change this equation to 4x minus 3y equals negative 12. All right, I'm going to solve for y now because I want to get it into y equals mx plus b. Or actually, this one works better because 4 and 3 are divided by 12, divide evenly into 12. I can do a different method as well. I can use my intercept method. So I could go x, y, put 0 in for x and solve for y. So 0 in for x leaves me with minus 3y equals negative 12. Y is equal to 4. So that would be my y-intercept. Put 0 in for y. 4x equals negative 12. X equals negative 3. So I have two coordinates I can graph. All right, that's one way to do it. It worked great because this value, I can divide these two values into that value nicely. Now, the other way to do it is to solve for y and get it into the form y equals mx plus b. So I'll just go through that with you. So I'm going to subtract 4x. So I get minus 3y equals minus 4x minus 12. I'm going to divide by negative 3. So 4/3 x plus 4. Okay? So both of those are simple methods in order to graph this. So let's graph it now. Okay, so using method number 1 here, I go to 0 and 4. Then I'd have to go up 4, right 3 over to here, and I would draw a line between those two coordinates. Using method number 2, I go to 0 and 4, and then I go to negative 3 and 0, which is right here, and I draw a line between the two coordinates. Now, first things first, when I look at the inequality, I don't see an equals to. So that means then it is a dashed line. All right? So when I draw this now, again, remember your arrowheads. It's a dotted line, which means that all the coordinates on that line will not satisfy the equation. And at this point, I have to decide, do I shade above or below the line? So if you remember, I select any coordinate and I plug it into the equation. If the equation is true, I shade that side of the line. If the equation is not true, I shade the other side. So I like to use 0 and 0. We know that. So I put 0 in for x and 0 for y. 0 subtract 0 is 0. Is 0 less than or equal to negative 12? Is 0 less than negative 12? The answer, of course, is no. So that's not a part of my solution. So my solution is up here. Whoa. So I shade my region above that line, and then I would always select another coordinate in this area, and if I plug it into the equation, it would be true. Okay? So the first thing that you do is you change the inequality to an equality. Graph that line. Whatever method you want to use to graph that line, graph that line. I make sure that it is a dotted line because it's not an equals to, right? Okay, so I have 4x minus 3y is less than negative 12. I graph the line, and then I select a coordinate. In this case, it was 0 and 0. I put that into the graph, all right, to find out whether or not it satisfies this. So I went 0, subtract 0. 0 is 0 less than negative 12. The answer was no, so I shade above that line. Okay? So let's do this again. There's no questions. Let's look at page 365. So I have 2x minus 3y is greater than or equal to 15. So the first thing I do is I switch it to an equation. This one, my intercepts aren't so slick. So what I'm going to do is I'm going to change it to y equals mx plus b. Subtract 2x to the right side and then divide by -3. So now to graph the line, down here, 0, -5, up 2, right 3, over to here. And because it's an equals to, it's a solid line. Do that. So now I have my line drawn. Now I have to determine whether or not I shade the top or the bottom. So I'm again going to pick 0 and 0. So I put 0 in here. That makes that 0. Is 0 greater than or equal to 15? No. That means 0 and 0 is not on this line. So it is down here. And I've now shaded my region. Okay. All right. So this part of it shouldn't be any issues with it. All right. We've done this again, like I said. I'm going to leave example 3 until tomorrow, or sorry, till likely tomorrow. I'll just do the example 3. The hard part for you guys, if you remember from applied, was actually writing the equations out. The graphing part was the easy part. So if you can get, if you can do today, you could go all the way to basically question 5. So if you got 1 to 4 done, there's a number of different questions there in terms of graphing. So if you got 1 to 4 done today, that'd be a good start. And then we'll work on the problems together tomorrow or Wednesday. Let's do it. Let's get to the end of 4 for Wednesday. I'll go through the problems with you on Wednesday. And that way you can do, on Wednesday, you can do 5, 6, 7, 8, 9. So, and 10. So if you have, if you don't have any questions tomorrow, Amron, speaking to you, you can sleep in. All right. I won't go through anything new with you tomorrow. I'll just answer the questions from 1 to 4. I'm just teasing you. 1 to 4. You get 1 to 4 done for Wednesday. That's good. And then I'll work on the problems with you guys on Wednesday. Okay? Any questions this morning? About anything?
I did have a question about the review for chapter 8.
Okay.
Go over it.
Absolutely.
It was question, let me find it now.
Sure.
Question 6, I just couldn't get there. I suck with word problems, so I just didn't know how to set it up properly. I tried doing it both ways, but I just...
Okay, they give you the 2 equations, correct?
Yeah.
Okay, so why don't we, and they're already in y equals form, right?
Yes.
Okay, so then let's go, excuse me. Let's let them equal each other.
Okay.
So I have minus x squared plus 12x minus 28 is equal to minus x squared plus 4x add 2x. And I'm going to subtract 2. All right, so adding x squared cancels the x squareds out, so that's 0. Subtracting 4x makes that 8x here, and subtracting 2 makes that 30. So now I just have 8x equals 30. X is equal to 30 over 8.
Okay.
Okay?
Yep, that's a lot more simpler.
Okay.
Thank you.
Hey, no problem. All right, anybody else have any issues this morning with any of this? So if you finish 1 to 4 for Wednesday, that's ideal. We'll work on the applied part of it, on Wednesday. Okay? That's all I have for you this morning. I will tune off. If you guys want to stay on, you're more than welcome to, but I'll come right off the chat this morning. All right? Everybody have a great day. We'll talk to you tomorrow or Wednesday.
Thank you.
Thank you.
Problem.
Thank you. See you.
Bye.